Now, let's see, consider a list of vectors, and the question is, are they dependent or independent vectors? If a vector is dependent on the other vectors, it means that I can write that vector in terms of some linear combination of the remainder vector. Consider the vectors 1, 2, and 2, 4. Can I or cannot I create one from the other? Let's see. Just looking at the entries of the vectors, I can see that the vector 2, 4 is twice 1, 2. Or said in another way, the vector 1, 2 is 1/2 of 2, 4. That means that I can create one from the other and vice versa. And therefore, these two vectors are said to be dependent on one another. Now, looking at our second picture, the question remains, is it true or not that I can create one of these vectors from the others? Let's take an example. 1, 2, can it be created by combining 3, 0 and 0, 3? The answer is yes, you can, because I can multiply this by 1/3 and I can multiply this by 2/3. If I multiply this by 1/3, I get 1 here, the 1 here. If I multiply this by 2/3, I get the 2 here, the 2 here. So I can create the pink vector from the yellow and blue. But now I'm going to look at the same idea of the dependence from a different perspective. And that different perspective involves rewriting these two formulas. Let me just write this formula in another banner. 1, 2 minus 1, 2, 2, 4 is equal to 0, 0. So 1, 2 is minus 1/3, 3, 0 minus 2/3, 0, 3 is equal to the vector 0, 0. I have now a linear combination on the left side is equal to a 0 vector, and another linear combination on the left side is equal to 0. So when two or three vectors, depending on the case, are dependent, it means I can create a linear combination that gives you 0, right? Can you see? Let me just write this thing again. What you see here is alpha 1, 2 plus beta 2, 4. Well, if I choose alpha 1 and beta minus 1/2, I get the 0 vector. This is the idea, the central idea. You can look at these in two perspectives. By saying that you can create one vector from the others is equivalent to saying that if you combine all of them, you can find coefficients that are non-zero that can create the 0 vector. I'm going to say this again. It's in summary here. It's a summary. U, V, and B are dependent. It means there are solutions of alpha U plus beta V plus gamma W is equal to 0, where these coefficients don't have to be 0. Think about it. Just think about it. If from this simple example here is the alpha, which is 1. Here you find beta, and the minus 2/3 is gamma. Just imagine if I choose alpha, beta, and gamma is equal to 0, this formula works. But the idea of dependence is that I can find solutions, alpha, beta, and gamma, which are not 0. I can combine the vectors and get the 0 vector. So alpha, beta, and gamma need not be 0. Of course, if they are independent, the only possibility is that they are 0. Let's see an example. Consider the yellow vector and the blue vector here. So I have alpha 3, 0 plus beta 0, 3 is equal to 0, 0. What is the solution of this thing? Well, the only possibility is alpha 0 and beta 0. You can see pictorially why. Because they point in distinct directions. That's it. Now, to say that W is dependent on U and V, meaning you can write W as a linear combination of these, means that U is equal to alpha U plus beta U for some alpha and beta. Or in other words, W belongs to the span of these two vectors.